In this video, I'd like to talk to you guys about optimization, right? But before we actually go into the nitty-gritty of the specific concept, let's talk through this little problem here. So we're given 40 feet of wire, right? And we're told to make a rectangle. The question now is, what dimensions would you make this rectangle so as to maximize the enclosed area? Now, the word maximize should tell you that, right, that we're going to need to apply some of the stuff we've been learning in the last few videos, right? The concepts of extreme values, of mins and maxes. But how do we go from this relatively abstract situation of having 40 feet of wire and making it into a rectangle and going from that into maybe some equation that we could use a second derivative test on, right? It's not readily obvious. So let's go ahead and see if we can try and set this problem up, okay? And make this into something that we can actually apply our knowledge to. So the first thing I want to do is I just want to go ahead and draw what the situation looks like, right? So I've got this piece of wire that's 40 feet long, right? And what I'm doing here is I'm bending it into a rectangle, right? I'm bending it into a rectangle with some area A, okay? Now my goal, right, what I want to do is I want to maximize A. I want to maximize A. I just want to get I want to find a way to maximize that area. I want to see what dimensions of this rectangle I can make to maximize that area, right? So that's my goal. However, let's see if we can make this problem more mathematical, right? So let's put some variables on this rectangle, right? So let's call this X and this Y, okay? So given that, I know that my equation for area is simply going to be X times Y. Good, we now have some kind of equation to work with, but that's still not quite good enough for us to actually do calculus on, right? We can't use a second derivative test or anything on that just because, well, it's a function of two variables, right? So we're kind of limited there. So what could we potentially do to make this situation easier for us? Well, remember, this wire, we're only given 40 feet of wiring, right? Since we're given 40 feet of wiring, right, I can maybe take that into account, right? I could potentially take that into account to see if I could simplify this down any further. So given that I have 40 feet of wire that I'm bending into this rectangle, my total perimeter, right, if I add in those, has to be 40, right? So I can come over here, let's do that in blue, and I can say, all right, so 2x plus 2y would have to equal 40, right? Now, great, but how does that help me deal with this? Well, now what I could potentially do is I could solve for one of these variables and plug it back in there. So let's solve for y, right? So if we move the 2x over to that side, divide by 2, we're going to get y equals 1/2 40 minus 2x, which is just simply going to be 20 minus x. And now we have an equation for y in terms of x. So now I can dump that in here for y, and now I will have area in terms of just that one variable x. It'll be x times 20 minus x. And that's pretty amazing, right? Because now in just a few seconds here, just by drawing some pictures and using some of the given information, I've gone from this very abstract problem into an equation that I can use a second derivative test on and find an area, right? So we can actually even go ahead and take a second. We can use a second derivative test on this, find our critical points. We could actually find the exact maximum. We could find the dimensions that would actually maximize our area. I'll let you do that by yourself, but essentially what you'd get is x equals y equals 10. 10 feet would be your final answer there. So your maximum area would be a 10 by 10 rectangle, or a square would be your final answer if you actually went through that, right? And that's a pretty neat process, right? We went from something relatively abstract to an actual equation that we can do things with, right? And that's basically what optimization is, right? That's the entire process of optimization. All right, so let's talk more generally about what optimization is all about, right? Basically what you'll see in all these problems is you'll be given some kind of a real world example, some kind of a real world problem, and you're going to find some kind of an ideal setup, right? Your entire process will be to find this kind of ideal setup. In this case, in the past example, it was a set of dimensions, right? Or it could be a lot of different things that does one of two things. So we either want to maximize something good or minimize something bad. So when I say maximize something good, like just now we maximized area, right? So we maximized some kind of a usable space. You could also be maximizing things like revenue, right? That's a big one, and there's so many others. Right? You could also minimize something bad, right? Because remember, we can find both maxima and minima. We can minimize something bad, something like, for example, overhead costs, right? This is kind of useful if you want to start some kind of a business, right? Another thing we can minimize is time wasted, right? So for example, if you have a product that's in high demand, you want to get it out to the people as fast as you can, so you want to minimize the amount of time. So basically the whole essence of an optimization problem, right, is we're going from this kind of a real world setup, right? It's kind of a real world setup, and we're basically trying to find some final solution that will maximize or minimize some kind of quantity that we want, right? That's basically the whole essence of optimization problems. All right, so the last thing I want to wrap up this video with is to just go through the set of steps that you will see in every optimization problem, or pretty much every optimization problem, right? So we actually went through all of these in the example we just talked about. Maybe if I didn't talk about each of these explicitly, but you will have seen these, right? So the first thing we want to do, right, is we want to start with a goal, right? We want to start with a goal, which is to sort of lay out in stone what exactly we're trying to do or solve for, right? So in the previous one, we tried to maximize an area. The next thing we want to do is we want to find some kind of an equation, right? An equation, we're going to define some variables and write an equation that actually helps us achieve this goal, right? And that's one of the steps where we actually go from a more abstract problem in words to an actual mathematical solution. So this is where we got that equation A equals xy, right? That's kind of where this came from. The next thing we want to do, this transition is arguably one of the harder ones this is probably one of the harder, more time-consuming ones in optimization problems, and that is we want to use a constraint to simplify the equation over here into an equation of one variable, right? This is where we did that whole step, right, of saying, all right, remember 2x plus 2y equals 40. When we solved this for y, plugged it back in, that's encapsulated by this step, right? That's basically what we were trying to do here. And this is often the one that takes the most time, right? Because that's kind of the important step that turns this problem from a more abstract word problem into an extreme value problem, right? And of course, the next step, this is actually where we first start to use calculus, and this step is where we start to find extrema, right? And that's again what we've been working towards this whole time, right? To be able to get an equation of one variable that we can use one of our derivative tests on and find critical points and yet all that fun stuff and find whatever extreme value we're looking for. This is basically what we've been building towards. This is actually the only other place, like I mentioned, where we even use calculus. Okay, so that's that. And the final step, of course, we want to have a conclusion. And this step is basically where we actually answer the question. Right? So for example, if the question asks for dimensions, you want to go ahead and actually provide both, or how many ever dimensions you're being asked for, right? So that's basically all the steps. Coming up, I have a whole bunch of practice problem videos on optimization. I've already filmed them. I'll release them over the next few days. I highly recommend you look at them. Like look through all of them, because again, each optimization problem has a lot of subtleties associated with it. So the best way to get good at these is just to do as many of them as you can. So look through those practice problem videos. They're kind of long, but hopefully they equip you well to do well on these kinds of problems on whatever exam or quiz you have. Okay, so that's that. If you found this video helpful, please do like, share, subscribe, leave a comment, and check out some other videos. See you next time.